Dear students, in this session, we are going to discuss about the RISC processors and CISC processors and what are the differences between those two. That we are going to deal now. Basically, a RISC processor has less number of instructions, basic difference, and CISC processor will have more number of instructions in that particular set. Okay, all the RISC processors will have less number of instructions. All the CISC processors will have more number of instructions. This difference is basically here. In the case of RISC processor, we are going to use only two instructions, okay, for referencing the memory, for accessing the memory. Only load and store. Only load and store are the two instructions which are used to access the memory. Load means getting the data from memory, that is for loading. Storing means to store the data onto the memory. Only two instructions are used in most of the RISC processors to access the memory. Whereas in CISC processors, there are many different instructions are available to access the memory. Okay, there are many, not two, more than two, and many more are there. Okay, sometimes it may be 6. That depends on the processor, but not two. Okay, more than two instructions are available in the CISC processors to access the memory. There is only one difference, simple difference to understand. Okay. Then here, most of the instructions in RISC processors use registers as operands. At the same time, RISC processors will use less number of addressing modes also, whereas CISC processors will use more number of addressing modes. Why? Because they are going to, that means there are different, many instructions will be there, and at the same time, majority of the instructions will access the memory in the case of CISC instruction, that is CISC. Many instructions will be there which will be related to memory data access. Okay. Here the basic differences I will give in the form of a table. Okay. Basically, I will give only one clarification here. The RISC processors are meant for the high-end computing purposes. CISC processors are meant for our normal use, general purpose applications, or that is for desktops, etc. Here, we will go through the differences which are given in the table. The first difference, I will go through it. Okay. If necessary, I will explain in more detail here. RISC stands for Reduced Instruction Set Computer. Okay. The name, this is the abbreviation. The full form is this one, Reduced Instruction Set Computer. In the name itself, it says that reduced instruction set. That means which has less number of instructions. Here, CISC stands for Complex Instruction Set Computer. Okay. The name itself says that. Okay. The instructions which are there in CISC are more, at the same time, complex. Why it becomes complex? They are using more addressing modes. Okay, not less number of addressing modes. It is using like register indirect or index addressing modes. All those things will be used by here. Okay, all most of the addressing modes are used here. Whereas here as in RISC, only less are used. Here RISC processors have simple instructions taking about 1 clock cycle. The average clock cycle per instruction is 1.5. Here, what about this instruction, simple instructions taking 1 clock cycle? 1 clock cycle means 1 T states. Already a T state is nothing but, here clock cycle is nothing but, what do you mean by clock? A clock is nothing but, okay, if you take any CPU which will be driven by a clock, okay, which will be driven by a clock means which is driven by frequency. I think we are talking about different frequencies of processor. The processor may be same but with different frequencies. That means the clock cycles are different. Okay, the clock time is equal to 1 by frequency will give the clock time. That is time period. That is called clock cycle. Okay, cycle time. That is the time period. Okay, each instruction will require 1 or 2 here T states only. That means most of the instructions are having 1 machine cycle here. In the case of RISC processors, most of the instructions will have 1 machine cycle, or sometimes it may be 2 machine cycles, not many machine cycles. The RISC processors will have less number of machine cycles when compared to CISC processors. Machine cycles means basically instruction is divided into machine cycles. Machine cycle is divided into T states. That is the division. The instruction cycle means already this is the instruction cycle means the entire thing is called instruction cycle. That means the time taken to execute an instruction is called instruction cycle. The time required to execute an instruction is called instruction cycle. So which requires opcode is 1 machine cycle, operands are other machine cycles. If there are 2 operands, totally we require 3 machine cycles. One for the opcode machine cycle, another for operand 1, another for operand 2. The operand machine cycles will be either read cycles or write cycles. Okay, like that, again that each machine cycle will have again T states. Okay, each machine cycle will be divided into 4 T states or 3 states. That depends upon the processor. 3 or 4 T states. Generally, opcode will be 4 T states. Sometimes the memory, the read and write machine cycles may have 3 T states. That depends upon the processor again, not specific. Okay. Here the RISC processors have simple instructions. Simple instructions in the sense which will have only opcode, or it may have maximum 1 operand or 2 operands also in case. Those 2 operands will be again registers only, not memory. Okay, like that, the size of instruction, okay, the number of bits, okay, required for instruction will be less. That is, RISC processors have simple instructions taking about 1 clock cycle. So the average clock cycle per instruction will be 1.5 only, or maximum 2. Okay, that is average here. So in the case of CISC processors, has complex instructions that take up multiple clocks for execution. The average clock cycle per instruction will be 2 to 15. Okay. Here, in the case of CISC processors, if you take any instruction, the number of T states required for that instruction will be much more. Why T states is much more? That means there are machine cycles. Okay, the number of T states more because of there are multiple machine cycles are required for a particular instruction. Okay, here the T states in the for a CISC instruction will be more. The T states required for a RISC instruction will be less. That's the meaning of this. Next, it has hardwired control unit. Okay, it has a hardwired unit of programming. Hardwired unit of programming means if you take any CPU, the CPU will have basically 2 parts. One is arithmetic logic unit, another one is control unit. The CPU will have 2 parts. Okay, one is ALU, another one is control unit. Here, the control unit used in RISC processors is hardwired control unit. Okay. Here instead of that, you can write it as directly. It has a hardwired control unit. It has a hardwired control unit. It has a hardwired control unit. Always, if you take any device, the hardware device will be faster than a software device. If a hardware device and software device will do the same function, okay? If a function X will be done by the hardware and software, okay, same function, okay, but okay, if we are doing function X by using the hardware, will be fast when compared to by using a software. That is in general, not only for this case, that is in general. If you do any function by hardware, it will be fast than by using a software or by using any program. Why? Because that that is one of the reason. Another one is another difference will be there in the case of programming control unit. Okay, the advantage is you can change it easily, but in the case of hardware, we cannot change it easily. Okay, flexibility, that is what you call as flexibility. The flexibility is more in microprogramming control unit, which is used in CISC processors. In the hardware control unit, the flexibility is less, but this is faster. Hardware control unit is much faster than this. The CISC controller has a microprogrammed control unit, okay, which will be slow, but flexibility will be there in the microprogrammed control unit than hardware control unit. Okay, these are the differences. In addition to this, the next next one is simple register related addressing modes are used. Already I told that, this is already told to you. Okay, majority of the instructions are related to register related addressing modes only, not memory related addressing modes. In the RISC processor, majority of the instructions, okay, will be used, okay, will be used register related addressing modes, okay, whereas CISC addressing instructions, okay, some instructions in CISC processors, they are using memory references or memory addressing modes. Memory means main memory, whereas here the RISC processor, we are using register related addressing modes. That means we are going to access the registers for getting the data, whereas in CISC processors, okay, we are going to use or we are going to access the main memory to get the operands. That's why obviously the main memory speed is much less than the speed of a register. So the time taken to access the data from a memory, okay, is memory means main memory is much more than the data accessing from a register. That means with in less time you can access the data from register, okay, but for accessing the data from memory it takes more time. Okay? Then multiple register sets are present. Here many registers are available. Already we have what the CPU contains. The CPU contains ALU and control unit and the register set. Okay, these three are the parts of any CPU. Okay, here in the RISC processors, the number of registers it contains more. The RISC processor contains more number of registers in the CPU. That is called CPU registers. Whereas in the case of CISC processor, the registers inside the CPU are less number. Why? Because it is costly. The register memory is costly when compared to main memory. The register memory is costly when compared to the main memory. Okay. Here the RISC process will have more number of registers inside the CPU, whereas this process will have less number of registers inside the CPU. Then RISC processors are highly pipelined. Okay. Pipeline means here while executing the instructions, fetch and execute. That is, the operation is divided into parts. Okay, while doing one part, another will do another part. That means there is parallel operation. That is like pipeline means which is uh, uh, not purely parallel, but similar to such kind of activity. Okay, these processors are highly pipelined. Okay, here CISC processors, they are normally pipeline, but very less activity. In the case of pipelining, it supports less cases, whereas here most of the cases the CISC process supports pipelining as well as parallel processing. Parallel processing and pipelining, this that will be supported by more in RISC process, less in CISC process. Then execution time is very less. Already I told that. Why execution time is very less? The size of instruction is less. The size of instruction is less. The size of if the size of instruction is less means, or if the opcode size is less, obviously the decoding time will be less. So overall, the execution time of any RISC instruction will be very, very less. Whereas here in the CISC, the execution time of any instruction is very, very high when compared to this. That is more than double, more than 3 times like that. Okay, it will be very high, it will be very less. That means very fast. That means the execution time of any RISC instruction is very fast. CISC instruction is very slow. That is what I told just now. The decoding of instruction is simple because of less number here. Here, decoding of instruction is complex because of more number of instructions. Here, more number of instructions. Here, less number of instructions. Okay. Because of this reason, this will be very fast, this will be slow. Very fast means execution time is less. Fast means execution time is very less means fast. Okay. This is the execution will be fast because of this reason only. Okay. Here it will be execution time is very high means slow. Because of this reason. Then the most common RISC processors are these things. All these are the RISC processors. All these are the RISC processors. Okay. But in JNTUK third year syllabus, we'll have PowerPC and ARM in some of the examples. Okay. All these are the RISC processors. ARM and PowerPC we need to discuss at a later stage. All these are the RISC processors. The most commonly RISC processors used are these things. Okay, that is ARC, all these things. Then CISC processors are these things. Okay, your Intel family, AMD, Motorola family, all these are these things here. The RISC architecture is used in high-end applications such as video processing, telecommunications, and image processing, and even space applications also. Okay, RISC processors used in servers. At the same time, RISC processors are used in high-end applications like space processing or video processing or telecommunication or image processing, okay, or speech processing. So all these things. So wherever the high the fast is required, execution time will be less, and very fast processing is required. Okay, there RISC processors are used. That means especially servers and high-end applications. Whereas CISC architecture is used in low-end applications. Low-end applications means normal PC, okay, general home appliances, general systems where we are using day-to-day activity, not in research purpose. Day-to-day activity, whatever you are using, okay, there you are using CISC processors. Whereas for the high-end purpose or research purpose or dedicated applications, we are going to use RISC processors because of they are very fast when compared to CISC. RISC processors are very fast when compared to CISC processors because of all these reasons. Okay. Thank you.